Hello and welcome to the video on 30, 60, 90 triangles. By the end of this video, you should know the properties of 30, 60, 90 triangles and know the relationship between the sides. A 30, 60, 90 triangle is named that because it has angles of 30, 60, and 90 degrees. A 30, 60, 90 triangle is made by having an equilateral triangle where all the angles were 60 and dropping an altitude from there. Well, because of that, there's going to be a relationship between their sides. If the original object here was equilateral, I know all of its side lengths here are going to be congruent to each other. So these original three lengths right here would all be the same. So for example, if I knew that this length here was 10, and this length here would be 10, and this whole length down here would be 10 as well. So if I go back to my original 30, 60, 90 triangle, it should not be a great stretch of the imagination for me to be able to tell you that, hey, if this is 10 and the whole length down here is 10, that this altitude is really a median as well, meaning this piece down here is 5. So this third side down here we'll just call x, and we can find a pattern as to what that is always going to be in relationship to the other two sides. If this was actually our lengths here, I could figure out what x is by, again, using the Pythagorean theorem. My two legs would be x squared and 5 squared. When I add those together, it would equal my hypotenuse squared, or 10 squared. Well, x squared plus 25 would equal 100 then, and then x squared would equal 75. When I square root both sides, I would get x as the square root of 75, and then to reduce that square root, I get the square root of 25 times the square root of 3, or in other words, 5 square roots of 3. Well, I could do this any number of times, but if you've already watched the 45, 45, 90 triangle video, you know that there's going to be a pattern here, and we can kind of see it already. So if I assign some variables to this to try to find a pattern, my short side down here I'm going to call x. My hypotenuse was always going to be twice as much, again, because if this is 5, this was 10, it's always going to happen that the hypotenuse here is twice as much as that short side. And now what's going to happen over here? Well, if our pattern holds, it looks like it's the short side times the square root of 3, and that is exactly what it's going to turn out to be here. Let's actually try this and show it using the Pythagorean theorem. If I didn't know that this was the square root of 3 times the short side, if I had a 30, 60, 90 triangle, if I knew the short leg was x, the hypotenuse would be twice as long. We can use Pythagorean theorem here to figure out what this longer leg over here is. I'll call it L temporarily. Well, x squared plus L squared is going to equal 2x, the quantity squared. So that means x squared plus L squared is equal to 4x squared when I square both terms inside the parentheses. When I subtract my x squared, I get the L squared is equal to 3x squareds. And when I square root, I get L is equal to, well, the square root of 3 I can't really do much with, but the square root of x squared is just x. So the length is always the square root of 3 times more than the short side. So that leads us to our properties for 30, 60, 90 triangles. In a 30, 60, 90 triangle, the length of the hypotenuse, h, is always going to be 2 times the length of the short side, or the short leg, I'll say, which they call S, and the length of the longer leg, L, is going to be the square root of 3 times the length of the shorter leg. So if my hypotenuse is H, my short leg is S, and my long leg they called L here, well, basically the relationship between those is that the hypotenuse is going to equal 2 S's, and the long leg is equal to the short leg times the square root of 3. Let's try a few sample problems. When you're doing these problems, the first thing you want to do is identify what parts you have. For problem number 1, we look here and I have the short leg. The reason I know it's the shortest leg is because it's across from the smallest angle. If I have the shortest leg as 12, my hypotenuse is going to be twice that much, or 24. And the long leg is going to be the square root of 3 times more than that. So x is 12 square root of 3. Problem number 2, let's start by figuring out what we have. In this case, it looks like they're starting with the hypotenuse. Well, if the hypotenuse is 10, then the short leg is half of that, or 5. And if x is 5, the long leg is the square root of 3 times more than that. So y is 5 square root of 3. And one more, problem number 3, if I give you the long leg to start. Well, the long leg to start remember, is usually the short leg times the square root of 3. So in this case, the long leg is equal to the short leg times the square root of 3. Well, my long leg is 21. That's equal to the short leg, which is x, times the square root of 3. So I'm going to work backwards to solve for x here, and I'll divide by the square root of 3. Well, if x is 21 divided by the square root of 3, just like on the 45, 45, 90 triangle video, I cannot have that square root in the denominator, so I'm going to rationalize it. To rationalize this, I'm going to multiply by some form of 1. The form of 1 I'm going to use here is the square root of 3 over the square root of 3. The reason why I'm going to use that is because when I now multiply these, I get x is 21 times the square root of 3 over the square root of 9, because the square root of 3 times the square root of 3 is 9. By multiplying by whatever's in the denominator down there, I've made this into a perfect square. So x is 21 square roots of 3 over 3, and then 21 over 3 will reduce to 7 square roots of 3. Well, now that I know the short leg is 7 square roots of 3, we need to get the hypotenuse. And if you remember, the hypotenuse is twice as long as the short leg. So double 7 square roots of 3 would be 14 square roots of 3. That brings us to the end of the 30, 60, 90 triangle video. I hope you have a wonderful day.